Okay, let's take a look at the practice test problem. So I've got this practice test posted in Hawks. Okay, it's not worth any points, so it's just a study tool to get you ready for the test on Monday. Um, but I'm going to work through all the problems. Your numbers may look a little different when you go to do it online. Okay, but they'll be the same types of problems. Okay, so I'll probably split this up into 3 or 4 videos to make it a little easier to find what you're looking for if you need help with a specific problem. Okay, so let's start with number 1. So it says find the missing terms of the sequence and determine if the sequence is arithmetic, geometric, or neither. So if we look at this one, we got 4, 6, 8, 10. Okay, it looks like, what's our rule here? It looks like we're going to take our last number and then add 2 plus 2. So this will be 12. This will be 14. Okay, and since we are adding some number over and over to get the next number in our sequence, that means that this is an arithmetic sequence. If we were multiplying by some number over and over, it would be geometric. If we had some other rule, then it would be neither. So adding or subtracting by some number to get the next number in the sequence is arithmetic. Multiplying or dividing is geometric. And then if we have some type of different rule, then it's neither one of these. Okay. Let's go on to number 2. Number 2 says Ben needs to mail a USB drive to a friend. He uses 45-cent stamps and 7-cent stamps to pay $2.43 in postage. How many of each stamp did Ben use? I'm sure there's some way you could set up a fancy equation and figure this out exactly, but you don't have to. Okay, you can just use trial and error. There's nothing wrong with that. So one way I like to work this problem is I'll take the $2.43, the total, and divide that by 45 cents, 0.45. And that comes out to 5.4. So the most possible 45-cent stamps we can use is 5. So I'm going to make 2 columns. I'm going to make a 45-cent column and a 7-cent column. And let's just try out some different combinations here. So the most 45-cent stamps we can use without going over is 5. Okay, so if I use 5 45-cent stamps, I'll do 5 times 0.45. That'll be $2.25. Okay. And then if I do 243 minus 225, that'll leave us with 18 cents. Okay, and there's no way we can get 18 cents out of 7-cent stamps, so that one's not going to work. Okay. So then what I would do is I would try to go down by 1. So I try using 4 45-cent stamps. So 4 times 0.45 gives us $1.80. And then we would do 243 minus the $1.80 gives us 63 cents left over here. Well, let me move that over a little bit. Okay, 63 cents. So is there any way we can get 63 cents out of 7-cent stamps? Yeah, if we do 63 divided by 7, that's 9. So we could use 9 of these 7-cent stamps. So we would use 4 at 45 cents and 9 at 7 cents. Okay. You can just use trial and error on that one. No big deal there. Okay. Head to number 3. Number 3 says there are 385 students enrolled in an introductory geology course. If there are 7 boys to every 4 girls, how many boys are in the course? Okay, so we're wanting to figure out, it says we've got a ratio of 7 boys to 4 girls. That's our ratio, and we're trying to end up with a total of 385 students. Okay? So what we got to do is we got to come up with an equivalent ratio here. So we got to multiply 7 to 4 by some number that when we add the totals together, the total boys and the total girls, we get 385. So again, here you can just use trial and error. So maybe, let's see, we can do, maybe if we multiply by 50, let's try that. That might be too big, but I don't know, it's okay. Let's try it. So 7 times 50 would be 350 boys, and 4 times 50 would be 200 girls. So that's too big because we end up with a total of 550. Okay, so let's try something smaller. Let's try times 30 maybe. Okay, so 7 times 30 would be 210 boys. 4 times 30 would be 120 girls. What do we get there? We get 330. Okay, so we're closer, but we need to multiply something a little bit bigger than 30. Okay, so I'll put this in a box here. Okay, that was times 30. Let's try times 32. Okay, let's try that. All right, so 7 times 32 gives us 224. 4 times 32 gives us 128. Let's see how that works out. 224 plus 128. What do we get there? We get 352. Okay, we're trying to get 385. So we got to go bigger. So maybe times 34. Forgot my S there. Okay, so let's do 7 times 34. 238. And then 4 times 34. 136. We add those. We get 374. Okay, so we're getting closer there, getting closer. Let's try 36. That's what happens when the math teacher doesn't check the answer ahead of time. It takes them a minute to get there sometimes, but it's okay if it takes you a minute to get there. You've got time, so just work through the trial and error on these. And if you see a better way to do it, it's okay to do it that way too. Okay, so 7 times 36, 252. 4 times 36, 144. And add those together. I get 396. Okay, so that's too big. So I think we got it this time, finally. Right? We got kind of unlucky on this one. It took us several guesses, but let's do times 35. So 7 times 35, 245. 4 times 35 equals 140. And if we add those, yeah, we do get 385. Okay, so how many boys are in the course? Okay, boys are the number on the left, so for our final answer, how many boys are in the course? 245. 245. All right, let's go to number 4. Number 4 says determine the cardinal number of the set. So we're into the set theory sections here. So cardinal number, if it doesn't spell it out like that and say cardinal number, it might say find this thing that looks like the absolute value of m. That means the same thing. And the cardinal number is just how many members or how many elements are in the set. So we just have to count how many elements are in the set. In this case, our elements are letters. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in this set. All right, 10 letters in here. So the cardinal number of m is 10. Okay, so cardinal number is just how many elements there are in there. So you just count them. Right. Now, number 5. Let's see, and I do have one little error here. It says C minus. It's supposed to be C equals. Had a little glitch there for some reason when I copied that over. Okay, this one says write the set using the roster method. So the roster method is just where we list out every element that is in the set. Okay, and you got to make sure you use all the proper set notation. So it's calling it set C. Okay, so we're going to stick with that same name. Our set C equals, and then since it's a set will have a curly bracket, and then we're going to list out all of the elements that are in this set. So if we read what it's saying, what the set builder notation is saying, it says A such that A is between 17 and 31, and A is an odd number. So that's telling us that the elements in our set are all the odd numbers between 17 and 31. And since these have the equal bars down here, that means we'll include 17 and 31 if they're odd. Okay. So 17 is odd, so that's where we're going to start, 17. And then we'll go to the next odd number, 19, 21, 23, 25, 27, 29. Our next odd number is 31, and that's where we stop. Okay, so there's our set C, all of the odd numbers between 17 and 31. Okay. One more in this video. Okay, so let's look at number 6 here. It gives us the set A, or all the letters in whiteboard. And our universal set, our universe, is all the letters in the alphabet. And then it tells us to find this thing, A with a tick mark. Okay, that tick mark means complement. Okay, so we're trying to find a complement. So what does the complement of a set contain? It contains everything that's not in the original set. Okay, so if we're looking for a complement, we want all the elements that are not in A. And it gives us our universe. So probably the easiest way to do this one, since we've got so many letters to deal with, is to go through and cross out the ones that are not going to be in our complement. So in A, we had the letters in whiteboard, so we got to leave all those out in A complement. So we'll leave out W, H, I, T, E, B, O, A, R, and D. Okay. So the ones that are left are the ones that are in A complement. Okay, it's everything that's not in A. So in A complement, we've got C, F, G, J, K, L, M, N, P, Q, S, U, V, X, Y, Z. I almost ran out of room there, but there's everything that's in A complement. It's all the letters that are not in A. That's A complement.